for the Earth observation community, there hasn't been this drive of sharing machine learning models. For the Open Earth Monitor project, my goal was mostly, again, the OpenEO currently misses stable machine learning API processes to make it easier for users to be able to use as many models as possible.
I don't think I've seen a project that's funded at that scale that's purely dedicated to make Earth observable GeoAI backend software systems that positively impact our daily lives. I want us to pause there for a minute and unpack that. We're here to amplify African tech stories and elevate technical brilliance. This is the GeoHabari podcast with Yariwo Kitio. Hi guys, welcome to another episode of the GeoHabari podcast. This is the Tech Stacks and Architectures series. We have intentionally curated this series to take us on a learning journey to understand the individual building blocks of powerful tech stacks that make geospatial technology tick. From programming languages, databases, softwares, cloud infrastructure, and so much more, we feature individuals sitting at the very core of developing these systems end to end. Welcome to the Tech Stack series. To support the show, please follow us on Spotify, Apple Podcasts, or wherever you get your podcasts. If you enjoy the episode, leave us a rating or review. It helps bring visibility to the podcast. Hi guys, welcome back to the Tech Stack series. It's been such an insightful journey. And this week we are looking into GeoAI and machine learning. We've previously had an episode on GeoAI and machine learning, and we featured Chris in that episode, and Chris talks about what he does as a GeoAI engineer. This week's episode is focused on what it takes to build GeoAI backend software systems. Allow me to welcome the guest for today, who is Brian Pondi. Brian works as a GeoAI machine learning researcher at the University of Munster in Germany, and I found his profile really fascinating. So his about on LinkedIn actually reads, he's a geospatial researcher / software engineer focused on building geospatial machine learning backend software systems that positively impact our daily lives. Brian also has a paper that he published recently called Machine Learning Model Specification for Cataloging Spatiotemporal Models. So allow me to welcome Brian to the pod. Hi, Brian. How are you? It's really good to have you, and thank you for saying yes to coming to this particular episode.
I'm good. Thanks, May, for hosting me. And yeah, I'm happy to be here, and I like what you're doing. So let's have the conversation about your AI. Yeah.
And before we get deep into the conversation, I'm curious to know what your experience has been like moving to Germany, working as a researcher there. What's that like? Also, yeah, did you have any culture shocks, work environment? What's that experience like? How would you describe your experience working as a GeoAI researcher in Germany?
Yeah, cool. Thanks. I can say it's actually an interesting space to be into. And research here, what I've noticed in Europe, there's a tendency to do research in a consortium. So you find that EU funds a project, and you're like 20 organizations in different European countries, different minute culture and perspectives, right? So it's usually quite interesting in that way. And since I'm in a university setup, I can usually say, okay, there's a good work-life balance tendency, yeah, which apparently Europeans like to prioritize. And then what again I've tend to realize is there's also a lot of investment in good infrastructure. At least when the universities try to be almost close to the industries with things like high performance computers, yeah, and this good, so you can find there's really cutting edge research being done in the university. Generally, yeah, what I mostly dislike is usually the weather, especially the winter is brutal. So, for considering someone from like me who's from Kenya, which is a country in sub-Saharan Africa, and Also, yeah, the people usually in Kenya tend to be way jovial, you know. But here, people are more reserved and things like that. Yeah, yeah. So that was like the biggest culture clash that someone usually encounter when they move into a new country. Yeah, and also technically, I've had experience working with the people from multiple different countries, right? And the thing is, you'll find like Kenyans or the British or some other nationals are usually not maybe direct when they think there's an issue or whatever, but you'll find Germans, they usually tend to be straight to your face, you know? So you might feel it's like someone attacking you, but that's not the case. It's just that people usually tend to be direct instead of navigating around an issue when trying to deliver their opinion to you. Yeah. So that's something that one needs to get used to. Yeah.
I think the main differentiator there is, the infrastructure, what you're saying, like access to high performance computing, especially in, the age of AI and, how resource intense. That must be really exciting. I just to briefly talk about your background and how do you get to Germany? How does that come about? What are some of the engagements that you think were very pivotal in getting you to this particular point in time, briefly?
Oh yeah, we can probably have to start with my studies. So initially in Kenya, I studied geography, as a bachelor's degree. But then when I was about to leave, I think in the uni, I was just curious what kind of roles are there. And this was in the early 2015, 14. And there was, I started seeing a trend of geospatial developer. So it was kind of a new role compared to the usual geospatial analyst that you use desktop software. And for that case, I started kind of learning programming. Then later on, after finishing, I joined S3, I think as an internship, and that's where we met actually. And it was interesting to again learn the commercial software. And then after that, I left to join a research organization that I can say across the various continents, but it's called International Center for Tropical Agriculture. From there is when we started using tons of satellite processing, and you can think to automate satellite processing, this really needed programming with Python, yeah. Later on shifted to Dubai, where I joined a product company for real estate. And for this case is where I started getting proper into how backend system works, because it was a real estate portal and it was mostly setting up the special infrastructure, because real estate is all about location. Location is key. And it was from a simple thing like someone wants to live close to where they go to work, plus not far from their kids and things like that. So these kinds of data sets were missing in the Middle East, that is Dubai, and so it was populating that, and also for that led to things like machine learning, where we generate data sets and also carry out house price prediction and things like that, which really need solid location spatial features. And when I saw this, I was quite fascinated with the software engineering world for how the product management works and things like that. And then I looked, okay, where can I do a master's that combines geospatial and computer science stuff? And this is how I found the master's in geoinformatics in Germany. So that's how I got to Germany. So it was again interested in this kind of approach, and then joined the master's program. And the good thing with Germany, so they allowed someone to work part-time. When you usually go there, so it's usually 20 hours a week. And after my first 3 months in Germany, I also got to start working in the German industry. Yeah, so being in Europe, it gave me access to roles that I can do part-time. When I was again fully joining the industry full-time, my professor liked what I did in the master's and offered me this full-time research position, which also the good thing with Germany, you can always again do a PhD, but also be fully employed as a staff in the university. And again, I was thinking in future, if I want to go into policy, things like having a doctorate helps. So that's my rough idea of why I'm in research, but also like what we are doing. And I love the project that I am in, which is called Open Earth Monitor Cyber Infrastructure, which is an EU-funded project.
Oh, wow. Also, meaning, Brian, the AI machine learning researcher role is both a full-time job, but you're also working, but it's also your PhD. Is that accurate?
Yes, so this is quite a rare concept in Germany. They usually give full-time position for a few STEM roles where they feel there is competition with the industry, because for academia or research top talent, you will always find that they employ you full-time and also let you do your own research as you work as a full-time staff.
We've had an episode on GeoAI before on the pod. Shout out to Chris. And he talks about building high accuracy machine learning models. And this is what are then used to power up drones, robots for different use cases, right? From identifying buildings, crop types, crop health, all these use cases. Coming back to what you do, Brian, which intersects with that episode somehow, your role is geospatial researcher in GeoAI and machine learning. On your LinkedIn, I'll keep referencing that. You talk about you focus on building GeoAI backend software systems that positively impact our daily lives. I want us to pause there for a minute and unpack that. What does that actually mean in practicality?
Okay, cool. I can say mostly it's technically just a software engineering kind of role, but definitely with the focus on machine learning, taking it to production, and making it publicly available. Because we can think it about this two ways. They can be, I can put in theory like if you're a data scientist in a, let me say, a supermarket chain, right? When you create a model to plan to do an expansion of your of the chain so that the key stakeholders can decide where to expand next. Usually just have your scripts and then your result is out and then you share with the stakeholders. So it's internal. That's more CI design. But for a backend system, think about it. You want, like I mentioned before, people want to buy homes, then they need to know the probably what's the ideal price for this property. So definitely for this, there'll definitely be a database, data sets, right? And then there's a programming language that is possible to have APIs. So it can be like Python, but then you have a framework like Fast API or Django. And then also the trained model. And then when when there's a new property, and then this can be inferred and the right price or the estimate of the cost, right? And then people need to access this, and so they can access this via either a web portal that has a front end, or then there's just an API that some companies want to consume your API to make this as a commodity or as a service, right? For the public to access. There's a need for a backend. And technically in software, if someone is not familiar, there's usually the front end, what you see, right? If you where you can log in, log out, or visualize the map. For example, in Google Maps, a simple example is the map you see. But then behind it, when you put your destination, origin, all this is calculated on the back end, and you don't tend to see it. And that's technically how, again, for machine learning it is. There'll always be some server somewhere hosting the platform with some code, with the logic running behind. And yes, and for machine learning, then there will be specific ML for the kind of issue or the problem you're trying to solve, also hosted somewhere in the backend. Does that answer, or I need to dive deep?
It does answer. So I'm trying to relate what you do, Brian, as a GeoAI researcher to the Open Earth Monitor Cyber Infrastructure project. And you'll briefly talk about that project in detail. But maybe for context to the audience, that's an EU funded project that's worth 12.7 million euros. If you're like me who thinks in Kenya shillings, that's like 1.84 billion shillings. So it's a pretty huge project. I don't think I've seen a project that's funded at that scale that's purely dedicated to make Earth observable. So I think it's a really impactful and interesting project to look into and read about. I'll include the project details in the podcast description, and you can just go through the website and look at some of the products they had. I think one of the ones I saw, there's a biodiversity monitoring tool. There's one for production estimates for a couple of countries within the continent. There's a couple of interesting projects. You can go through it and look at what we're talking about. Maybe you can talk about your interaction with what we see on the front end bit of that portal. So the maps you get to interact with, what is your interaction with what we see as the audience in the front end?
Oh yeah, sure. So in context, there is again this project. Parts of my work is an extension of already existing component. There's this thing called OpenAPI, which is a specification, and the idea for it was to do a standardization of workflows. Mostly it was initially for Earth observation, but also now extending to vector data. And the idea was that there exist multiple platforms. So from Sentinel Lab, you can think the usual Google Earth Engine and whatever. But all these things have got different APIs where if you're using one code here, you won't be able to use the same code in this other backend. So you'll have to kind of rewrite your code. So to make it easier, the idea was to simplify so that there's an overlay that technically hides the specific codes for how the varying codes of all these different backend system, and there are also many in Europe. And then you just use, if you use one code and you try to reproduce the same workflow, you can just carry the same code and use it across the backend services. So this is like it can be a Python code, an R code, or a JavaScript code, but it will still be the same code that you use across platforms. Yeah. And then this was quite a success, and then it led to, again, federated systems where it's called OpenAPI platform. Maybe someone can Google and see the website. So you can use your code, you can send your code, but then you don't know which backend system you're sending it to. It can just be as random as long as it meets all the functions or the processes you need, it can generate your results. Now, for the Open Earth Monitor project, my goal was mostly, again, the OpenAPI currently misses stable machine learning API processes. So my first objective was to define machine learning and deep learning APIs so that to make it easier for users who have got limited knowledge of machine learning or deep learning to be able to use as many models as possible and to easily interchange. You can just think of, instead of them defining their own deep learning CNN framework, they can just use like one line and say, okay, I want a CNN model and want it to apply here. So it's not really like, it's not LLM, but you use one line as to, and the code is really like less than 10 lines of code. You can have a deep learning model and do a classification and things like that. And also the other concept that you are having is there are a lot of models that people are generating, but then it's lying idle on their computer or in the organization. And then the idea was again to have a reproducible or model reuse. So you can think about, for example, you have a crop yield prediction model for somewhere in Kenya sitting in your computer, and I want this model. Maybe I want to do the same thing and improve on, or maybe a quick research. Instead of me retraining a model, it would be better if I can find your model and then reuse. So again, the research is also to have such kind of APIs that can enable, okay, people can host their datasets locally. They don't have to host in a central point, but if organization just host their models and have public API, then it can be easily accessible and people can easily consume it and use. So this is the rough idea of the research. So it's not finished, it's still progress. But then how is it applicable? So in the EU, let me say there's many use cases. For example, again, we can just stick with the crop yield classification. For countries to know, for example, what they need to import or whether there will be deficit, it will be good to predict at times maybe there's a bad weather, there's flooding or whatnot, which affects crop production. The rough idea of this is with these simple workflows, a country or an organization or whatever can be able to use these APIs, and then they be able to do the crop yield the prediction, and then okay, it's gonna be a surplus or a deficit or whatever, and then we need to import or we will have enough to export, right? But then it's all based on simplifying the process. So our goal in the general in the project is to simplify the workflows and develop tools and to make it accessible. So from example, for me, it has mostly been the ML API specification. And apart from that, developing prototype tools, because this thing has not technically been done before. I try to simplify various machine learning models to be consumed easily in a backend, and also to quickly enable sharing and reuse of models. Yeah, and yes, there's places like Hugging Face, which is a platform to host models for the open source, but for the Earth observation community, uh, there hasn't been this drive of sharing machine learning models and things like that. So it would be good to save on time and just to promote community for people to really be open to reusing and sharing each other's models than it's sitting in some organization somewhere after you've trained. No one knows about it, but only you. But so it's towards again pushing open science, which is again key idea in Europe or in EU. I can to be precise. Yeah.
From what I'm hearing, is the project dedicated to democratizing AI? And one of the other things I'm also picking is, for example, we are used to accessing maps through portals, and normally you're purely accessing the data set. But from your explanation, it also looks like the interaction will go beyond accessing the maps and the data, but it's also accessing the machine learning models that were used to build the maps that we see on the front end. For example, I'm looking at the crop prediction map that has been created on the Open Earth monitoring platform. Then I'm not just looking at the data itself, but if I want to access and download the models that were used to create that, then the project gives me access to that. Is that accurate?
Yeah, you can say, yeah, part of it. So there is definitely also data access, but there's also tons of data that will be generated on this project. So also making that accessible. So there's this principle called FAIR principle, which is findable, accessible, interoperable, and reusable. So that's the rough idea. And yes, it's not only for models, but for data, for software. So it's trying to cover multiple components. For me, I'm focused on the ML side of things, but yes. So it's a big project with different focus on, yeah.
What does the creation of this API frameworks look like that's powering up the sharing and access of these machine learning models on the platform? What does that process look like?
Yeah, so the first thing that you do, at least since you're building on top of the OpenAI, so for example, if we define our ML API processes, the good thing is if you're already using, if a user is already familiar with Python or R or JavaScript or Julia, at least these four languages, we have clients for this. So one can easily define the workflow a language that they're familiar with, and these languages are quite common, at least in the data science space, so it's okay. And then there was this concept of the metadata plays a huge role. So, for example, if you're saving a model, definitely it will make sense for one to know when was this model generated, the spatial extent, the temporal extent. Because, for example, maybe a crop prediction model in Europe might not work ideally in East Africa, right? And so having this metadata and be able just to filter with this kind of metadata makes it easier for you to pick the right model. Did it use maybe an organization use TensorFlow or PyTorch or scikit-learn. So it needs to know, okay, what was used and things like that. Then you'll know based on this, you can easily reuse this on your computer or with the infrastructure you have, and then it will be able to be beneficial to you. So
As you're
metadata is
explaining
also
it,
really
Brian,
key. Yeah.
my head has gone to Swagger because Swagger does this, um, design, building, documentation of APIs. And I'm wondering, is it something like that, or am I oversimplifying the concept around creating API frameworks for this particular project?
Yes, no, it's kind of like that. So there is so we technically use like so built on it's now Open API, right? Because I think Swagger changed the name Open API. So it's technically use Open API to do definitions, and then since it's funded by EU, so you can think about if any organization again wants to build a backend and it's probably funded by EU, they need to follow this specification because people are familiar with this already, and then they can decide to add more functionalities. But yes, they need to check, okay, if I want to say load, if I'm using this stuff, load machine learning model, every person who's building the backend in EU, it doesn't need to be a function for loading machine learning models. It needs to be defined like that, so that a user, whenever they shift from this product to this product to that, it will still be easy to use with the same exact code. So it's like, yes, Swagger and OpenAPI to do the specifications and to make, this is the standard, and if you want to build your stuff, follow this approach. Yeah.
As you're creating these frameworks, there are a couple of factors I'm picking that would make the project successful. So one is obviously what you've explained, the FAIR principles of making sure, it's the models are findable, accessible, interoperable, and are reusable. And then the second one is I'm also picking these definitely multi-stakeholder involvement and collaboration. From a GeoAI researcher perspective, as you're creating these frameworks with these factors in mind, what are some of the challenges that you face as you're creating these frameworks? And again, you mentioned there's no benchmark around machine learning models and frameworks around it.
In whichever project, dealing with humans is always the critical or the key focus of every project. So generally, to pinpoint, yes, it's having an interaction with people, and the good thing is there's usually a stakeholder meeting, or we have a monthly meeting where we try meet to think, share progress, and then it's like internal support. Before people take things into consideration, really need to showcase, right? The progress, what is it, how will it be beneficial to them? Just the way it usually is in a product-based company. And then if people see this, this is going to be useful in this angle and that angle, and then it starts being accommodated. But yeah, one really needs to push it, demonstrate it, and then it turns out to be okay.
I'm wondering how different this is from Stack, or how this compares to Stack, the spatial temporal asset catalog. And I'm just thinking how one of the key things that was such a game changer with Stack was the discoverability of data, right? And again, for the audience, I'll post a link maybe to reference Stack and you can read about it. I'm wondering how this compares to Stack, right? Is there a correlation there between Stack and these frameworks that we're creating for machine learning models to enable us to, use, reuse, access these models that are powering up the maps?
Yeah, so it's kind of like that. So Stack has been a key game changer, especially for accessing Earth observation data easily, right? You just specify your area, time frame, less cloud coverage, or what percentage of cloud coverage you can tolerate, and then you get the data. The same thing. So right now there's an extension. I think we had a paper about that. Probably you haven't seen it, but it's called machine learning. The extension is Stack MLM, so Stack Machine Learning Model Extension, and this has already been built, and then there was a paper for it that we did with some fellas from multiple countries actually, because it had like nine authors. So there's already a Stack MLM extension, and it defines all the parameters you can check, right, that you can use to get a model, and this works actually. Yeah. So it just needs to get more adoption. So the problem is it's still new, because it was just like last year. That's when the first release happened, late last year. But then it's an open source thing. One can ask for suggestions, improvement, and things like that if it misses. But it should be good if it's heavily adopted, like the way Stack for Earth observation data was greatly adopted. Yeah, so it's not only in the project, but technically the whole Earth observation community. This is the drive. It will be nice thing to do.
Okay, that gives me a really good understanding of, the entire goal of the project and the idea of having discoverability with models as well, beyond just data. Are there bits you're looking forward to or excited about when it comes to tools and technology, and how that's going to change how we look at sharing of models and democratizing access to models?
Yeah, so first of all, I just like the concept of one open source. So first Stack was a huge game changer, right? And then just this drive for things to be open source and people willing to make their workflows or solutions open source. That's a good thing. There's this rise of foundational models. Yeah, it has started as a concept, and if maybe we'll reach a level where foundational models will be simple or easy to run for everyone. Yeah, it will be nice, especially if they can do easily downstream tasks without you having to worry about crazy retraining. Yeah, so this will definitely lead to a huge adoption and reuse and. Yeah, I think because the big companies, like, for example, I think IBM has done a lot of massive foundational model. I think there's Prithvi and there's a new one called Teramind, and definitely they use tons of data sets and with the huge computing resources and things like that to come up with these models. And even though I think they're still kind of big, maybe, but it would be easier if they're smaller so that people from, I can say, maybe countries that don't have the resources to run these heavy models or organization. You can think even about organizations or countries or individuals, but they want to leverage this model. It should be easy to use. So maybe hopefully there's a time when you get to where running these models locally or in a simple manner, it will be doable. Like you are a simple user, you want to do your land use classification, and there's a fantastic model. It should just be easy, a plug and play. So hopefully we will get there.
This kind of reminds me of the excitement that was around cloud computing when it was just new, especially how that changed how we look at GIS, image processing, and tools like Google Earth Engine. I feel like we are sort of getting into, another sphere of getting excited about models, discoverability, and what's happening in the AI world. What is in your tech stack or your daily tools of trade? What does that look like when you're creating this machine learning frameworks?
Yeah, so usually for the API specification, again, it's the Swagger thing you mentioned. So it's now OpenAPI, right? And usually one also needs to be familiar with JSON and JSON schemas. Yeah. And then since I'm in academia, I usually look into multiple languages and but primarily Python and R. So I key. So for example, if we go to R, there's packages like Plumber, where you can also define REST APIs and things like that. And you will be surprised that R can go into production and you can have a backend in R, because this is something I've tried and also published a paper called It's OpenUCubes, which was kind of technically a platform built on R for prototypes. And then there are many packages in that, like if you're working with data cubes, which is these digital cubes, for example, and also R has got something like SF. And then for Python, there's definitely many tools. Python is usually a key solid programming language, especially when it comes to data. So for when dealing with the stack, again, it has got the PyStack, right, where you can just use to fetch the data and use stack and xarray to make the data sets into a data cube. There are many machine learning stuff. So the key one is scikit-learn that everyone uses for random forests and root nodes. And then there is TensorFlow used to be popular, but it faded, right? Now most people use PyTorch or Torch as a framework for deep learning. So if someone is learning afresh, I can say maybe they consider diving deep into PyTorch. And what else? So there's again, when dealing with datasets, there's this problem with the scaling, right? So because especially when you have large datasets, more than your maybe the RAM of your computer, one can always consider to use something like Dask. So this in Python, it helps. It's like it chunks your data into pieces, yeah. And then when it's processing, it processes it in chunks. And for this, you are able to work with at least bigger data sets. Another key thing I can say is usually when you're scheduling. At times you schedule things to run. Maybe you can think about it. Which use case can we give? Maybe monitoring forest or deforestation in near real time. You might need to check if there's any deforestation every time you get a new data sets, right? So there's things for scheduling like Airflow or Prefect. So Prefect is works solidly, and this is the kind of key tools one can look into. Since I've worked in with people in consortium and I've also seen federated systems, I've actually noticed that sometimes one might actually have to dive into, if you're using massive Earth observation datasets, one might also find it based on the use case, using languages like Scala might make sense, or because they have got frameworks like GeoTrellis, and it's also really solid for heavy computation, because you can find at times you find that the use case that you want or the platform you're building, if it's for something like East Africa, then it makes sense to think of a different tool set, even though it might not be that common, but it makes the job done and it makes your life easier. And at times you start finding people diving into languages like Scala, or these are the languages like Rust that are not quite common for people who do data analytics or data processing use. But yeah, it works. So being an open mind and just keeping in touch with the community and ready to adopt a language, because they're all tools, but the fundamental concept of doing projection, clipping, transformation, it's usually all the same when you're handling geodata.
Okay. Thank you so much, Brian. I'll just to wrap up this session with a quick fire question, which I've been asking guests through this series. If your code could speak, what would it say about you and why?
Oh, well, that's a funny question. Let me see. What? Hmm. Maybe I'm passionate, or yeah, but also changing a lot. So I listened to this podcast, but I think it was talking about principles of software design. So the idea is usually that people usually at times think their first idea is the best idea. Once they implement thing, they leave it like that, but then they try to come up with always a second idea. Once you have a second option, you might even find the second option is better.
Thank you for sharing that with us, Brian. Are there opportunities to contribute to the Open Earth Monitoring Cyber Infrastructure project? And yeah, and any resources you might have for people in the audience who might be interested in the GeoAI machine learning niche.
No, for contributing right now, I think it's let's start with the contribution. So right now it's mostly focused. Definitely the people in the consortium are contributing still on that heavily, but I think after the whole phase of the project is kind of toward the end, or everything is solid. These codes are open source, so anyone can do suggestions and whatever. And even now, one can look at the code base, because there is also Open Earth Monitor GitHub repo, and if they feel there's something they need to make a suggestion on or contribute on, it's always the community is always open. And then for how to view ML or generally software, for me, I usually tell people that it's still a general software. Yes, you have this geodata, but you usually just still need to learn from the fundamentals of everything. So for machine learning, instead of before putting the geo AI, it's the AI. So just you already have, if you have the geospatial background, yeah, just learn the key AI. There's this book that I have. It's hands-on machine learning. With scikit-learn, Keras, and TensorFlow, even though it's TensorFlow, I can recommend someone to learn Torch later, but the fundamentals of this book is it's really nice. And then generally you're dealing with systems. So, and what I like about this system design interview, it's that it's got some also location-based features like Google Maps and whatnot and things like that. And it just shows you technically, still teaches the concept of how to think about if you were to scale something, if you were to have this kind of issues here and there, whatever, all software issues. So it's a nice one. Yeah.
I will share the direct links to the books that Brian has shared. So if you're interested in getting in the GeoAI machine learning software development space, I think they would be very useful. And yes, thank you so much for tuning in. Brian, do you have any parting shots before we end the episode?
Yeah, for me, it's usually a proponent of continuous learning. Just striving for knowledge always makes you to be good. So I can say, yeah, people to do that. If you do 30 minutes a day for that's for a year, it's massive in the end. Yeah. Yeah, no one was born knowing everything, so it's a learning phase for life, and it's good to embrace it.
That is the end of the episode. Thank you so much, guys, for tuning in. Once again, this was the GeoAI machine learning episode with Brian Pondi, and we're looking at what it means to be a GeoAI researcher, and he specifically works for the Open Earth Monitoring Cyber Infrastructure Project. Please find all the details of this particular project in the podcast description. Until next time, bye.